everyone, and welcome to Discover Engineering's Chats with Changemakers. I'm your host, Kavya, and I'm a senior from New Jersey. And I'm also a member of SWE Next, which is the Society of Women Engineers' leadership program for high school girls. And every month, I interview a guest from the engineering community. Today's a special day because it's not only the season 5 premiere for Chats with Changemakers, it's also World Teachers Day. And we want to take this moment to thank the educators around the world, including all the teachers who are tuning in today for educating and inspiring our students. Okay, so let's get started. Today I'm chatting with Ben Dopp. Ben is a 3D printing specialist at TE Connectivity. Ben, welcome. We are so excited for you to join us today.
Hello, Kavya. Thank you for having me.
Really excited to have you as well. And so I'm going to be asking Ben a few questions to get to know a little bit more about him. And if you have any questions, you can type them in the Q&A box below, and we'll save some time to get to as many as we can. So without further ado, let's get started. Ben, can you please provide an overview of TE Connectivity and your role at the company?
Absolutely. So TE Connectivity is actually the world's largest connector company. And what connectors do, and it's a way to connect circuit boards or electronics to other circuit boards or electronics. And TE is actually the world's largest provider of connectors. Believe it or not, everybody tuning in today or watching this on recorded is probably within 3 or 4 feet of a TE connector right now, whether they know it or not. It's probably in their laptop, in their cell phone. Maybe if they're driving in a car, we make many automotive connectors or even connectors for airplanes. So whether you're flying in a 767 or maybe an F-16, we probably have connectors there too. And what I do is I'm actually a 3D printing specialist. So what I do is I 3D print lots of our pre-production, sample components, and even low volume production applications.
That's awesome, especially when you mentioned how widespread TE Connectivity's impact has been. And I know that you mentioned that you worked on products for automobiles, electronic, commercial, and military aircraft, so all these applications. How did you get into this space of 3D printing and manufacturing?
That's an excellent question. During my time in college, I actually never thought 3D printing would be what I wanted to do. I was lucky enough to intern in the 3D printing department where I actually am employed now at TE Connectivity. Mm-hmm. And that kind of lit that spark for me. I was like, this is awesome. This is really great. This is more than I ever expected. I had saw the 3D printers we had at school, which were pretty small in comparison to what we have at the industrial size. So I saw that and I thought, this is what I want to do. So that's kind of driven my adoption for 3D printing.
That's incredible. And so from your background, I know that you've spearheaded research in the selective laser melting of metals. So could you please tell us more about that process? How does it work and what is it used for?
Absolutely. That's one of the most inventive ways that we do 3D printing right now. So normally people get parts made out of metal. They'll do what's called subtractive manufacturing. They take a drill bit and they essentially drill away material. Well, what we're doing with the selective laser melting is we're actually taking a metal powder and we put a really high power laser to that. And we use that laser to selectively melt that powder back into a solid metal. And what that does is we build it up layer by layer by layer. And then we have a 3D printed, fully metal printed component. It comes out of the printer as a fully finished part. It doesn't require any secondary processing. And it's just as strong and tough as something you would have as you cut out of a block of aluminum or steel, which is awesome. It's used a lot in the aerospace industry and a lot in our connectors industry as well.
That's really interesting how there's like so much more benefits to the process. And I do want to dive into your background, especially as a mechanical engineering technician. So from all the projects you've worked on, what is the most surprising piece of knowledge that you can think of that not many people may know about?
I think the biggest surprise for me in particular was how important the connections between people really are. Especially in engineering, it takes a large team to accomplish any kind of goal, any kind of project. And I underestimated how important that was before I got into engineering. That was the biggest surprise for me. I mean, there's a lot of technical things that are a surprise, but coming in, I didn't anticipate how important it was, interperson skills were.
Awesome. And we actually have our first audience question from Miss Field's class in Utah. And and the class wants to know, what is the most challenging project you've worked on and why? It's a pretty good question.
That's a great one. The most challenging project I actually worked on is when I first started at TE. We decided we were going to take the next step on what my internship project was, and that was making 3D printed molds. Traditionally, whenever you're doing a molding application, they use metal, they use that drill bit and cut away, and then we shoot plastic into a metal part. It's really expensive and it takes a long time. We decided to look into how we can 3D print these molds instead, so they could be really fast, quick turnaround. What was challenging about it is it was a lot more difficult than what I initially expected. And this was the first time I really had to dealing with failure at this type of level, right? And dealing in engineering, that's something that happens. But failure is just another way to learn. And that was it was a big stepping stone for me to learn that's part of the process, to go out, try it. If it doesn't work, try something else, find the next step, the next way to do it.
So from what I'm hearing, you have to do a lot of innovating and iterating. And it's kind of like a very continuous process. And
Yes, ma'am.
well, I want to actually dive into like how your line of work has changed with the demands for sustainability, because I'm sure that's like another thing that also impacts the materials you choose or maybe the way you approach a problem. So how does that work?
Absolutely. Sustainability is a really big push happening right now through TE and through the industry at large. Sustainability means a lot to different people. But generally speaking, it's how do we reduce our footprint? How do we use less carbon dioxide? And how do we make less of an impact on our environment and our world? How we do that, it's very similar to whenever you think about recycling. Reduce, reuse, recycle. How can we reduce the amount of chemicals we use? How do we reduce the amount of resins, or what they call feedstock, the material that goes into print with? How do we reduce that usage? How do we reduce the amount of time our lights are on, how we're wasting power? That's the instantaneous, the fixes we're working on now. And then we're looking at the next generation of sustainability. How do we get biocompatible materials that are maybe printed out of some kind of reusable material, something recyclable, something that can be broken back down and reprinted with. That's kind of medium term. We're not there yet, but we're trying to get there. We really want to get to the point where all of our materials are completely sustainable. We don't have any kind of carbon dioxide footprint that we have to worry about. And that's coming very, very soon. So ongoing with sustainability, and hopefully just gets better as we go forward.
That's really exciting to hear the short-term and long-term vision. And I think you mentioned, was it 3D bioprinting? Is that one of those goals that we're kind of aiming for? So that's
Absolutely.
awesome to hear. And so since you're working on these challenges of sustainability, I'm curious to hear, how do you view your job, and in what ways do you think it encourages you to be a change maker?
I think just additive manufacturing or 3D printing, what I do, you kind of have to be a change maker. You have to have that vision, because we're taking components where TE's been around for a long, long time, Kavya. So we have parts that might have been from the 60s or 70s or 80s. Well, how do we update them so we can make them with the newest process, so they can print a little bit faster or better or higher performance with less impact on the world? How can we make it faster, better, stronger? That's the change that we really drive every single day. And that's why I like being an engineer. That's the challenge that I love. It's the how do you find the solution to this problem?
Awesome. There's always some sort of evolution. So we have another audience question, Ben, from Jillian J. And she asked, what do you wish you could 3D print that you can't yet?
So it's something that I can't 3D print, but some people are 3D printing. People are 3D printing houses right now. And I think that's really, really interesting. It goes back to that sustainability topic. You don't necessarily have to use concrete. You can use sustainable materials. It's a lot faster, a little bit less impact, potentially. Like I said, not something I do, but I would love to see the process and get involved in that at some point. And the scale's pretty awesome. Most of what I do is really small. And they're building houses. That's pretty awesome.
That's awesome. And I actually read about it recently, this idea of like growing homes and kind of using biological materials and that type of matter. So it's interesting how we're like kind of returning to our roots, which is nature. So I'm glad that you were able to mention that, because it kind of resonated with me. And speaking of the future, what is one future trend or development that you're most excited about?
Miniaturization. For me, I see the very bleeding edge of what's happening in 3D printing and manufacturing, which is awesome. Working for a big company like TE, it gives you that opportunity. And everything we have is getting smaller and smaller and smaller. The things that go into your cell phone and your laptop. Now we're making components that might only be 1 millimeter by 1 millimeter by 2 millimeters, and they're getting smaller than that. So we're going to be making parts that are less than a millimeter in size, that have contacts and connectors, and they have sensors built in, and these can live inside of your bloodstream, or it could be inside of a bio pill that you take, and it takes different parts of your body, your blood oxygen level, your blood pressure, and it can feed that back out to the doctor. I'm really, really interested to see where we go in the miniaturization front.
Awesome. And I also wanted to hear, what changes do you think you'll see in the overall STEM field for today and tomorrow?
I really think we have just more worldwide cooperation. I mentioned a little earlier that one of the biggest challenges I saw early on was just how much we're interacting with other people and how working as a team is important. It's getting to be more and more that it's a global ecosystem. And we also mentioned it when we talked about the 3D printing for the houses, right? You're making parts with what's available in the location. And that's going to be more and more prevalent. So I won't make a part here and ship it to Germany. I can design it here, and I just send a digital file and they make it on the premises. So it might not be something we make it and ship it. They make it there in their locations, and just having that connections and really that worldwide connection, I think, is the biggest change I think we're going to keep getting more and more of.
That sounds fascinating, because now I guess every location can operate almost independently. I mean, there's still that collaboration, but some of those constraints go away.
Absolutely.
Yeah, so we have another audience question from Mr. Schaffer's class at Carroll Magnet Middle School in Raleigh, North Carolina. And that class has asked, how can 3D printing be used in the electrification of vehicles and buildings? And I do want to quickly mention that this question is actually related to one of the topics from Discover Engineering's STEM competition, Future City. So it's definitely something that's interesting that's been brought up, and we'd love to hear your perspective on that.
That is a really, really good one. You're actually hitting something that's really important to us as a company and to the additive field in particular. Electrification of automobiles has been a big growth for us. If you go back 5 or 10 years, maybe there was 5 or 10 connectors in a car. Now it's not uncommon for something like Tesla to have 500 or 600 connectors in one single vehicle. And that gets to be exponential growth over time, because it's not just how your car talks to the engine, it's how it talks to the infotainment system for your radio and your speakers, and how does it talk to your XM radio, and how does it communicate between other vehicles, or does it have some kind of visual sensor to have the automatic braking? And all of those require connections from somebody like TE or from another connector company, and that growth has been probably the biggest growth area for us in particular.
That's awesome. I really love how you always are talking about the future and all these possibilities. It's definitely exciting to hear about that. And now I kind of want to dive a little bit more into the educational side, so more on how you got started. And I was wondering, how did your associate degree in mechanical engineering technology prepare you for your current job?
My associate's degree in mechanical engineering technology actually is pretty much perfect for what I do in additive manufacturing. So whenever you get into engineering, there's several different types of engineering. It could be chemical engineering, biomedical engineering. Even when you get into a single field of engineering called mechanical engineering, there's subsets built into there. And mine's what's called mechanical engineering technology. And that means that during my time at college, I have a 2-year associate's degree. We spent a lot of time doing the hands-on processes, whether it's running a CNC, computer numeric controlled mill, or running 3D printers, or a lot of this hands-on problem solving applications things. It directly applies to what I do every single day. And something that's more theory-based is super useful, especially in a team environment, but to be the person making the product, to be the person running the machines and operating them, and to be the one solving those problems, having that hands-on skill in addition to that theory-based balances me out really, really well for additive manufacturing.
And I actually had a follow-up question, because you mentioned how you specialize in the technology side. So how do you keep up with the latest trends and evolution in technology so that you can apply them in your current work?
I think some of that is just my natural interest in 3D printing and the manufacturing part. So even in my downtime when I'm at home, I'm certain it's on my Google News feed, or I'm looking at 3D printing news, and that it kind of fits because I happen to have a job that I really like. But I'll keep up on those. I read those, and then we read a lot of what's called white papers, where it's going to be somebody explaining a new technology, a new approach, something that's never been done before. And that's the other side. I like to take that new approach, that thing nobody's ever done, and see if I can do it. See if we can apply that to what we're doing. That's kind of how we stay on top of what's new. It's keep an eye out for what everybody else is doing. Can we do the same thing, or can we do it better, faster? And trying to find that process or technology usually.
And did you have any mentors who inspired you to pursue the path that you are on today?
Absolutely. Thank you very much for asking this in particular. I have an excellent mentor in particular. When I started here at TE, there was a gentleman named Bob Zabricki. He's what's called a additive manufacturer users group, is the biggest 3D printer group with us. He's what's called a dinosaur in their group. He was part of the very first beta testing of 3D printers back in 1987. And I was lucky enough to work under him for 6 years when I first started here at TE. And having him as a mentor allowed me to both gain all of the knowledge on how the equipment works, how the theory builds in, how the physical properties work, but also allowed me to get all the kind of connections that we want out into the world, because he just knows everybody. Having a mentor that has lots of connections and knows everyone, I can't put a value on how useful that was to me. He has since retired. He's out probably taking a cruise right now. He takes 5 or 6 cruises a year, but he was an excellent mentor for me. I don't think I could have done it without him.
And those connections are really important because engineering is a very collaborative space. You have to constantly work with different people. And so really getting to know as much people as possible can help you like excel in those projects. And I think that's like a really important theme that I've been noticing in our conversation so far, the power of collaboration. So it's great to hear that and how your mentor was able to influence that in your path.
I still leverage that to this day. If I call somebody and I've never talked to them before, I was like, I worked with Bob Zabricki, and they all know him. So it helps me get a foot in the door sometimes. It's a huge advantage.
Wow, that's amazing. And in thinking of the students joining us today and in the future, what is one piece of advice that you would want to give to your younger self?
I would want to go back and tell my younger self to have faith and go forth and do the things that I was good at and that I liked. There's a lot of times you have people telling you what may be best for you, or maybe what you should do, or what you can do. Try and find what you like to do, what you're really good at, right? I went into engineering and I happened to find that I'm really good at 3D printing, and it's pretty fun. Obviously, I could talk about it all day long, right? Try and find that thing that you're into, that you don't mind checking out in your spare time, right? So like if you're not at school and you're really into woodworking or whatever it is, find the thing that makes it exciting for you and try and drive that way as much as possible. If there's a university class that you can get a degree in that, or maybe you go to a technical school, or find the thing that you like and try and make that your job.
I think that's a great piece of advice, especially for students like myself who want to like take our passions to the next level. So thank you for sharing that. We have another question from Francie R, and they asked, how does math skills and concepts pertain to your job?
That's another really good one. A lot of times I used to think I would never have any kind of need for math when I move forward into my real life job. And in reality, it's very opposite, right? I don't use necessarily all of the math skills that I use, but especially the things based on physics, I really use that a lot. So whether we're talking about loading conditions or having bending moments and things, and the physics part of math and the geometry part of math, I use a lot, right? So if I want to know, especially radii and the way that things work. Sorry, I apologize. This can get really, really technical, so I don't want to go super deep into that one. But overall, I use math skills every single day. A lot of the real world physics-based things because of what I do. And then a lot of the theory-based ends up being more along the lines of how do we deal with many different forces applied to the same component or part.
And as a follow-up question, what other types of engineering complement your line of work? So when you're collaborating with other engineers, what fields do they typically come from?
That is another excellent question. So my direct team, we're under our corporate technology arm. We have engineers that are we have 2 mechanical engineers. We have 2 materials engineers. So chemical engineering, I think, would be their official degree they got. And we also have another mechatronics engineer that does a lot of hardware and mechanical systems engineering. And they all kind of come together to kind of build us out. So I'm on mechanical, my direct boss is mechanical. Our corporate technology has the materials team. So we all kind of come together. I've seen civics engineers come into our team as well. So it can be a pretty big breadth of types of people.
That's nice to hear that there's always like so many different backgrounds involved in your projects. And we have another really interesting question from Christopher S. So what are your thoughts about about 3D printed food?
I'm not sure. I have not had the opportunity to try it.
Mhm.
The one time I had a chance, I was not brave enough to try it. I would probably now. I think it's going to be interesting. I don't think it's mature enough right now that I would go buy a 3D printed steak. I think the cost is going to be a challenge. Nobody wants to buy a steak that's $100. If you could 3D print a steak and it's $5 and it tastes good, I think people would buy it. But we can't do that right now. If it was $5, it tasted good, I would probably still eat it. Yeah, I'm undecided, realistically. I think it's an interesting application. I don't want to talk bad about it. I don't know enough. I apologize.
Oh, no, that's all right. And as a follow-up, what about a 3D printed spaceship, just like playing with these possible applications?
So that's actually, we do that now. A lot of companies, relatively space. I have some former peers that actually work in the 3D metals groups in California, whether it's SpaceX, Rocket Labs. They're directly 3D printing not only just housings, but some of their rocket motors almost completely 3D printed. Something like the Starlink or Starship, I think is what Tesla or SpaceX is calling it. The entire upper body is 3D printed in titanium. So 3D printed spaceships, I think, is a great idea. You can do really, really complex geometries. You can do things that you can't make. I mentioned that subtractive, cutting it out of a big block of metal. There's limitations with what you can do there. There's not really a limitation with what we can 3D print. I can 3D print almost anything you can think of. So that's a huge advantage. It stops that limitation, right? So you can let your mind invent whatever you could possibly think of.
And I think that's really nice to hear how 3D printing is shaping the future and it's being used. I didn't actually know that we're already 3D printing certain parts of spaceships. So that's awesome to hear about how that space is evolving very quickly. When you were in middle school, what did you want to be when you grew up?
So when I was in middle school, I thought I was going to be a professional baseball player, if I was honest. Looking back in middle school, I never would have thought that I was going to be an engineer, right? I knew I was pretty good at school. I was pretty good at math, but I never thought engineering would have been the thing I would be good at, right? And it turns out as I got a little older and I saw what I was good at and what I kind of ended up liking, it kind of fit. I was good at taking things apart. I like taking them apart, put them back together, see how they work. And it turned out that engineering really aligned with that. My middle school self, I don't know that I necessarily knew where I wanted to be or what I was going to be good at, right? I knew I loved to play baseball. So I thought, oh, I'll play baseball professionally. So much changes before you end up getting a degree and deciding where you want to go. Even when I went to university, I originally went as business marketing and not for engineering. Thank goodness I had some friends that were in engineering classes and they kind of convinced me engineering was the way. And I'm much happier doing this now. But I think my younger self would be a little surprised about, especially how successful we've become.
I think your story is definitely an example of the importance of redesigning your path and being open-minded to all the possibilities, especially because in STEM, there's just so much things you can do, pathways you can embark on. So just having that open mind is really important. And what is one skill that you think the technicians and engineers of the future should develop?
It's going to be something we kind of mentioned a couple of times. It's that interpersonal skill.
Yeah.
Even if you're not technically the most skilled or you're not necessarily the best at theory, if you're a good teammate and you can communicate well and people can rely on you, somebody's always going to want you on their team. There's several members of my team that are they are the best communicators. I can rely on them to do anything and I wouldn't let them go for anything, right? So that's something, effective communication and interpersonal skills. I can't mention enough how useful they really are.
And what would you tell kids who aren't so sure about engineering or who maybe think that they're not cut out to pursue engineering?
I was one of those kids. I would say, check it out. Go. So there's a lot of universities that you can go to, and you can go to a visit. Just take a visit and check out their engineering department. They're going to be doing tests where they're pulling things apart and smashing them together and seeing how strong glues are. And a lot of these tests, there's some things that are challenging, right? You're still going to have to do math and English and history. There's no getting away from some of those. But the trade-off to get to do the parts that you really like, go take a visit, see what parts you like, and it could be something like it's the right situation in the right place. There's certain universities people go and visit, and it really resonates with them. That's where they want to go. Or maybe you go to a technical school, like there's one nearby us called York Technical Institute. We have a graduate from there in computer systems, loves computer systems. Don't hold back. If you have the capacity and the availability to go see some places, even if you can go and say you're in the Harrisburg area or near a T connectivity plant, you can come in, we'll set up a tour, and you can come see what we do as a professional sometimes. So try and reach out and leverage anybody that you can talk to in a job that maybe you're interested in. Try and see what they do, what they like, what they don't like. Try and find somebody like myself that's going to be honest. I think that's helpful.
And do you need a 4-year degree to work in engineering? This was a question that we got.
That's a good one as well. So currently, I don't have a 4-year degree. I have a 2-year associate's degree. Working through TE, they are actually helpful enough to help me pay for my ongoing training to get my bachelor's degree. So you don't necessarily need a engineering degree, a 4-year degree, excuse me. I do have an associate's degree that got my foot in the door, and then a lot of the things we do are just so hands-on and so direct applications that learning the right way to work with people and how your equipment works, and just being diligent at trying to get better at what you're doing, you can stand out with or without that degree.
Great. And now we're going to do a few fun questions just to wrap up our conversation. So what do you like to do for fun outside of your work?
I really like to go fishing. I like to play like board games or even like video games too. I play with my nephews a lot. That turns out they're way better than I am. So they make me look bad, but I don't mention that. I don't tell everybody. So that's a secret between all of us, that my nephews are better than me at video games. But yeah, fishing, games, hanging out with family.
And another fun question that I had was, if there was one superpower you could choose, what would it be and why?
I thought about this a lot over time, actually. This is a fun question. I would really like to just pause time, be able to pause time and not age while time is paused, because I don't want to prematurely age to 80 years old. But if I could pause time, I could travel wherever I wanted. I could do anything I wanted without having the downtime. If I was really tired one day, I could pause time and I could sleep in and still get to work on time. I think being able to pause time has the most number of applications that I could use.
Awesome. And I think that's time for all the questions we have for today. Thank you so much, Ben, for joining us. I learned a lot, and I'm sure everyone who's tuned in also took away a lot, especially two of my favorite takeaways was, first, the focus on interpersonal skills, especially in engineering, where you're constantly collaborating and you have to sharpen your communication skills all the time. And the second takeaway is about just learning about the future and keeping up with it. We heard so many applications about 3D printing, and so it's really great to hear those possibilities. So thank you so much for taking your time today to share all of that with us.
It's my pleasure. Thank you very much for having me, and thank you very much for listening, everyone.
Definitely. And we also want to thank our sponsors, Bechtel, NCEES, and TE Connectivity. And a huge thanks to all of you for tuning in. To learn more about mechanical engineering careers, go to Discover Engineering's website at discovery.org and click on STEM careers. And also be sure to join us for our next episode of Chats with Changemakers, which is on Thursday, November 2nd. And there we will meet our next guest, Leah Baker, a chemical engineer who is also part of Society of Women Engineers like me. So see you next time, everyone. Thank you so much for tuning in.